solid 2x4 right to the corner. Or shut that.
So now we'll just build a little bit of open wall. So Jerry's going to build just the back side of the wall. As we're building, we can build one side or both sides. Why would I build just one side? Well, if I'm on a commercial job site and I have a real heavy rebar schedule and I want access to the inside of that wall to put all my verticals in, then I might just build one side of the wall. The inside panels, you'll watch, will fill back in. Really simple to come back and fill the inside panels.
Blow the bracing up if you pour in sections, the first course and then the next course. Do you leave the bracing on all the way to the end, or you take it out each pour?
The question is, do we leave the bracing on if we pour in sections? If we're pouring a taller wall all in one pour and we don't want a cold joint, of course the bracing stays on all the way through the pour. If we're pouring, like we were mentioning, where you might be above grade but you can't pour enough concrete, so you're going to be stopping somewhere. There might be some lower bracing that could come off. You're still going to want to keep your corner braces on. Depending on if you get past your openings, there'll be some bracing with the opening to keep concrete pressures from pushing in our wood bucks or plastic bucks or whatever is utilized. So that, yeah, if you get past that point, you might be able to take that stuff out. For the most part, I would say most of the bracing stays on. But if we do get past with concrete in a certain area where there was a brace, you could pop that off. The bracing can come off relatively soon. Most of the bracing can be removed off of our wall the next day after it's poured. Yeah, header bracing in a window, which we'll show, is really the only brace that we leave there for several days to protect from the weight of the concrete, from doing any damage to the concrete before it's secured above an opening. So you can see the open wall. And then we'll go through placing rebar inside of that wall. Gary's just thrown a couple of 2-inch panels in there. We do have some 2-inch panel users in the audience, so want to make sure to show that as well. Now the 2-inch panels that we're showing here, of course, are Dow or the blue. We promote the Dow or the blue as much as possible because it is the strongest of the 2-inch panels out there. Jerry does a lot of testing with polystyrenes, both our polystyrene and then all the 2-inch guys out there, whether it be Owens Corning or the Green Pactive stuff. There's several different XPS manufacturers, and Dow just tends to be the strongest by far.
You can contract with also. What's that? You get the blue and 9-foot also.
You can special order. You can special order the blue and 9-foot. A lot of times there's order quantities associated with that, and then lead times. So something to think about. You can put a 1-foot chunk. So we'll talk about at some point. There's little plastic tacks. Well, maybe Jerry can show them right now. They're called Insulated, and that's what we'll utilize if you're doing a 2-inch system, but you're going 9 or 10 foot, and you don't want to wait for the panels to come available. Then you can just tack another piece on. And while we're talking about the polystyrenes, might as well hit on the fact that, of course, our white polystyrene that you see there is an EPS, or an expanded polystyrene, which is different than that blue poly panel you see there, which is an XPS, or an extruded polystyrene panel. There's the Insulated. Jerry's just pushing one end of the arrow into the poly panel, and there's another end of the arrow that sticks into the one above it. So that just helps protect that joint while you're building. It's no problem to pour for that joint. Those tacks are not helping you for any concrete pressures. It's just helping keep it in place as you build, and to make sure that your panels aren't falling in. The lateral ties, as I mentioned before, the lateral ties are a must or standard with a 2-inch system. Yes.
Is there a difference in R value there a different R value between the two products per inch?
In the XPS world, or the blue or the pink world, those polystyrene panels promote an R5 per inch versus R4.6 per inch. So you get a little better R value per inch with the XPS. Question?
What's the reason then that you would use the blue versus the white? Is it because of cost?
The blue does tend to be more expensive, and it's very regionally more expensive as well. So in certain states or certain areas of certain states, it can be really expensive. In some areas, not as much. It's a much more volatile pricing structure to that stuff, and we can't manipulate it as well either. With the EPS, there's so many different things that you can do with it, like molding that panel right there, the hot wire cutting out big chunks just works easier with EPS. Molding different angle corners. I mean, there's a lot more flexibility with it. And then there's different schools of thought. We try not to bash either one because we can offer both. We can get that XPS at any thickness we want. We can do 4 inch, we can do 2.5 inch, we can groove it can look just like our regular system. So we can use either one, and some architects and some engineers are partial to one versus the other. And again, there's a lot of schools of thought on below grade, what's better and what's going to take on less moisture and what's going to breathe out. I can tell you in our experience, the EPS, yes, it takes on more moisture quicker than an XPS panel. However, being that it's more open cell, it breathes better as well. So an XPS is closer to a waterproof. It's not waterproof, but it's closer. Takes on less water, or takes on water slower, but it also takes forever for the water to breathe back out. So below grade, a lot of times you don't ever dry out because it takes that long for it to dry. So what happens when XPS takes on moisture is it can affect the R value. In an EPS, it very, very minimal effect. You can submerge